Hello, my amazing students. This is Mrs. A, and it is time for me to do 5.6. Some of you are taking this test tomorrow, so all the other videos are out there. 5.6 is the application portion where we're talking about applications for logarithms and exponentials, and I'm going to work one of each type of problem that is in the answer in the back of the PowerPoint. Remember, all your answers are there, so I'm going to do one of each type for this so that it doesn't go too long and you get the help that you need. So the first thing I'm going to do is number 1, which is a painting was sold in 1985 for $2 million. The painting was then resold in 1996 for $6 million. Assume that the painting's value increased exponentially. So, in other words, we can assume that the curve is going to be a sub t is a sub 0 e to the k t. So we can assume an exponential growth equation. All right. So we can use this. We use this for continuous compounding of interest. We use this for many different growth applications. So that is an equation you want to make sure that you know. Where a sub t is the amount after time, a sub 0 is the amount that we started with, and e to the kt, k is your constant that we have to often find out what that is. And then the t is the amount of time that you leave it in this process. So it says that it was sold in 1985 for $2 million. So 1985 was $2 million. And then it was resold in 1996 for $6 million. Wow, wish I had that kind of money, right? And assume that the painting's value increased exponentially. Find the exponential growth rate, k. So we're going to find k and determine the exponential growth function, assuming v sub 0 is 2. So basically, when they say v sub 0, they're talking about the amount that they put into this function, which here I have a sub 0. They're calling it v sub 0 because this is value. Okay, so the value of the equation. So now we're going to plug these things in. So we're going to start with 2 million. So we're going to erase our a to the 0 and write in 2. We're going to put in however many years this is. So 85 to 96, that's 11 years. So we're going to take out the t. We're going to put in an 11. Okay, we know that the amount after all of this time went by was 6. So it got sold for $6 million. All right, and then we are trying to find the k and then write the general equation that's going to go with it. So can I divide both sides by 2 and make it a little simpler? So that would give me 3 equals e to the 11k. Okay, so remember that when I get an equation that has my exponent, has my variable in it, I need to separate that by taking a log of both sides. Since we have a base e, we really want to take a natural log of both sides. So I'm going to take the natural log of both sides and put it on a new board. So here's what we have so far. We're going to get the natural log of 3, which is going to be on the left, is equal to the natural log of e to the 11k. Okay, so I go from this board to this board, and remember what happens with our log rules. The natural log of e3, I'm going to have to look up on the calculator. But remember that the exponent here, once I've taken a log of both sides, this exponent by the power rule can run around there and be a coefficient. So then we have natural log of 3 is 11k, and then times natural log of e. But we know that natural log of e is 1. So we end up with this, and then we'll have natural log of 3 divided by 11 is that constant that we are looking for. Okay, so that is the constant, and that's the exact value. There's no reason why you can't use that value when we plug it into a calculator. All right, so I got my calculator, and we're going to do the natural log, the ln button of 3, and close that up and divide it by 11. So this is what I entered into my calculator right there. And I hit enter, and I get 0.0999. 0.0999. I choose to give myself 4 decimal places, 0.0999. Exponentials and logarithms, I like to have 4 decimal places. This answer key rounded it to 1 decimal place. That really is pretty extreme to round it to a 0.1, and that's what they rounded it to. So let's write our answer. We've got our K. So now we're going to write the whole equation that we're going to use. The formula for the exponential growth is going to now, after we find out the K, we take everything else back out. So then we're going to have amount after time, or value after time, is going to be, the initial value is still 2, and then e to the K is going to be 0.0999, and then t, because they give us all of that stuff so that we can figure out what is going on, and then we plug it back in, take all those other things out, so that we get a growth equation that is good for any amount of time and for any, so that we could get it out. So this constant will remain constant. We always assume that over time. So let me show you your 3 boards again. So this one got a little messed up. This was board number 1. The 2 million erased a little bit, but that was board number 1. And then this was board number 2. And lastly, board number 3. And the final part of number 1 on the back of the PowerPoint. All right, so now we're on number 3, and I'm going to read the problem and start to work on the board here. The number of books in a small library increases according to the function b equals 6,400 e to the 0.04 t, where t is measured in years. How many books will the library have after 4 years? So here's the equation that they gave me on the problem. And this one's really pretty simple, because they just say, how many will they have after 4 years? So we're going to let t be 4. So we're going to take the t out and replace it with a 4. And 0.04 times 4 is going to be 0.16. So what we're going to do is always follow order of operations. We're going to do e to the 0.16 first. Then we will multiply that result by 6,400. So let's get our calculator. And so I'm going to have my calculator. We're going to do e, which is second natural log button. E to the 0.16 is the same thing as 4 times 0.04, and I get 1.17. And then I'm going to multiply that by 6,400, which was the initial amount of books, and I get 7,510. And that is the number of books that are on my answer sheet. So we didn't round up because it is less than a half there on the decimal portion. Okay, so now we're going to move on and do number 5. And it says Kimberly invested $6,000 in her savings account for 8 years. When she withdrew it, she had $7,097.62. Interest was compounded continuously. What was the interest rate on the account? Okay, so we know that when we're doing continuous compounding, we're going to use the PERT equation. So we have Kimberly invested $6,000. So we're going to use amount after time is the principal, or the original amount put in, principal times e to the RT. So this is our formula for continuous compounding. And so in this formula, Kimberly invested $6,000. So that's her initial principal. Okay, and then her, when she got it out, so her amount after time was $7,097.62. Okay, so she had a nice bit of growth there. And then it says she had it in there for 8 years. So T was 8 years. And then we're supposed to find what was the interest rate on the account. So they've given us all of these pieces of information. So now we're going to put each one of these pieces into this equation. And I'm going to use a different board so we can refer back to that one. So we're going to have A sub t, which is $7,097.62, is the original principal, which is $6,000, times e to the r, which we're trying to find out, times 8. Okay, so we're going to substitute each one of these items into the equation, and when we do, it's going to look like this. So that we have the amount after time, we have the $6,000 initially invested, we've got the e to the r, which is unknown, and times 8. Okay, so now we're going to find out what the r is by first, let's clear out that 6,000. Can we divide both sides by 6,000? So when we do that, 6,000 on the left and 6,000 on the right, we're going to divide by that, and that's going to cancel on the right. Now I'm going to leave this as exact as I can, and I'm going to use my calculator at the end. So what I'm going to do now, since I have everything I need is up here in the exponent of the e, base e, I'm just going to take the natural log of both sides, because that's how we separate the exponent from the e. So I'm going to take the natural log of 7097.62 divided by 6,000, which we can do in a little bit, is equal to the natural log of e to the 8r. Okay, so that's what we have now, but we know that once we take the natural log, we can take this exponent over here, the 8r can run around and be a coefficient, so that then we get 8r natural log of e, but then we know natural log of e goes to 1. So now we have the natural log of all of this is equal to 8r. So now we can just divide the left hand and the right hand side by 8, and we will have the exact value of the rate. So we're going to divide by 8 and 8. So now I'm going to get that cleaned up on another board. So we have, oops, I think I erased the wrong board. Oh well. We have natural log of 7,097.62 divided by 6,000, and then all of that divided by 8 equals r. Okay, so that is the exact value of r. So now we're going to find the approximate value of r. This is number 5 on the back of your PowerPoint. So now I'm going to take the natural log and I'm going to plug it in with the 7,097 divided by the 6,000, and then that gives me the natural log. So now I'm going to divide that whole thing by 8, and that's going to be divided by 8, and I get 0.021. 0, 0, 0, lots of zeros after that. Okay, so that is my interest rate. And so if I'm going to write it into a percent, wouldn't I take this decimal and move it 2 places to the right and say 2.1% was the interest on the account? And so that's typical what happens when you are compounding continuously. You can make a lot of money. 8 years is a decent amount of time, but because it's compounded continuously, you started with such a nice little sum of 6,000, it can do some nice adding up there. Okay, so this was one of the boards. Sorry, I erased one. I was not paying attention. So that was one of the boards that we used to work this problem. And this was the final board that we used to work that problem. So now we will go on to the next one we're going to do is number 6, because here we have to find an amount of time.